Hello everybody and welcome back to Chapter 9. So in our previous video we talked about using factoring to solve a quadratic equation and find the zeros. Today we're going to look at other ways we can use factoring to find interesting information about a quadratic function. So let's review a problem that we've done before we start using factoring today. A model rocket is launched from the roof of a building. Its flight path is modeled by h of t equals negative 2t squared plus 7t plus 4, where h is the height of the rocket above the ground in meters and t is the time after the launch in seconds. A graph of this model is shown. At what time does the rocket reach a height of 7 meters? As soon as we see this question, at what time does the rocket reach a height of 7 meters, what we know we need to look for is when the height is 7. Now, the 7 on the y-axis is here. So what I can do to figure out when the height is 7 is draw a horizontal line at that height. What this helps me see is that my rocket reaches a height of 7 here and here, which would be at approximately 1/2 seconds, so 0.5, it's like halfway in between the 0 and the 1, and 3 seconds. The follow-up question that we're going to kind of ask ourselves today is, how can we answer this same question without a graph, so using algebra? Because I want to know when the height is 7 meters, and in this problem, the h of t stands for the height. To figure out when my height is 7 meters, I can just replace the h of t with a 7 in this equation. So I would write 7 equals negative 2t squared plus 7t plus 4. Now normally when we've seen equations like this and we've used factoring to solve them, we've always had this be equal to 0. And having a 0 was really important because it allowed us to use the zero product property. If there's a 7 here, we can't use the zero product property. So what I'm going to need to do next is rearrange this equation by subtracting 7 on both sides in order to get this equation to equal 0. So if I subtract 7 on both sides of this equation, you'll notice I'm writing the minus 7 underneath the positive 4. And the reason I'm doing that is because those are like terms, so those are about to get combined. When I combine the 7 and the minus 7, it makes 0, which was what I needed in order to use the zero product property. Then I'm also going to combine the 4 and the negative 7. So I would have negative 2t squared plus 7t minus 3. Once I have an equation that equals 0, so this side of the equation must be 0, what I'm going to do is use factoring to solve this. So I know that as soon as I see a negative coefficient, my first job to do is to factor out that leading coefficient of a negative 1. So the first thing I'm going to do is the GCF, which in this case would be negative 1, and what's left would be positive 2t squared minus 7t plus 3. Then I'm going to use the box method to factor this. So I'm going to draw my boxes. I'm going to fill in the leading term, so the 2t squared into the first box, and I'm going to fill in the plus 3 into the last box. I know that I need to make a negative 7, so if I draw my crisscross and I figure out my m and my m in this problem would be 6 and my a would be negative 7. So the only factor pairs I'm going to use here are 1 and 6, and I'm going to make them both negative. So I'm going to have negative 1t, negative 6t. Now I'm just going to do common factors. So the common factor for this column would be 2t. Then I would need a t here, a negative 3 here, and a negative 1 here. I can figure those things out by just thinking, what would I need to multiply to make that inside stuff? So my new factored equation would be, I'm going to drop down the negative 1, and I'm going to copy in my 2t minus 1 and my t minus 3, which is equal to 0. And the reason it's equal to 0 is because this was a 0 over here. We were trying to solve an equation that was equal to 0. So now I just have to make each of my factors equal to 0. Negative 1 will never equal 0, so I don't really need to worry about that. 2t minus 1 equals 0 is an equation I'm going to need to solve. So I'm going to add 1 on both sides, and I'm going to have 2t equals 1. I'm going to divide by 2 on both sides, and I'm going to have t equals 1/2. And then t minus 3 equals 0 is another equation I'm going to need to solve, and I'm going to get t equals 3. What you will notice about these two answers, t equals 3 and t equals 1/2, is that they are the same two answers we found up here. This is just a way to do the same problem if you don't have a graph. So, what are the steps we're going to use when we need to solve by factoring? First, we're going to make sure our equation is equal to 0. What that means is that we may need to rearrange the equation before we can start factoring. Then we are going to factor completely. That means first check for a GCF and then use the box method to factor the rest of the problem, if necessary. And finally, we're going to make each factor equal to 0 and solve those equations separately so that we can find our multiple answers. Let's go ahead and look and see some examples that we might need to know how to do. So for problem number 1, it just says solve by factoring. If I'm going to solve this by factoring, my first step is to get this equation to equal 0. So because it equals 14 right now, I'm going to subtract the 14 on both sides in order to make the right-hand side become a 0. Now on the left-hand side, there are no like terms that can be combined. So I'm just going to copy down the x squared, the minus 5x, and the minus 14. Next, I'm going to factor. So in order to factor this, I'm going to start by looking for a GCF. For this problem, there is no GCF. Therefore, I'm just going to use the box method. So I'm going to fill in my x squared and my minus 14. I'm going to figure out my m and my a so I know what numbers to fill into the other boxes. My m would be negative 14 and my a would be negative 5. The factors of 14 that are going to make 5 are 7 and 2, and I would make the 7 negative. So I'm going to fill those into my other boxes. Then I'm just going to do the common factor. So the common factor for this column would be x, which means there needs to be an x here and a 2 here and a negative 7 here. So my factored version of this equation becomes x minus 7 times x plus 2, and I'm going to bring down the equals 0 because this equation equals 0. Finally, I'm just going to make each of these factors equal to 0 separately. And I'm going to solve them each separately. So in this case, x would be 7, and in this case, x would be negative 2. In other words, there would be 2 answers to this question. For problem number 2, again, I need to rearrange this because I need my equation to be equal to 0, and right now it's equal to 12x. So I'm going to subtract 12x on both sides, which means because there are no like terms, I get 3x squared minus 12x equals 0. Now I'm going to factor, so I'm going to check for a GCF first. In this problem, there is a GCF, which would be 3x. And what's left over would be x minus 4. And again, I'm going to bring down the equals 0. Now I'm going to make each of these factors equal to 0. So 3x equals 0 and x minus 4 equals 0. If I'm going to solve the first one, I need to divide both sides by 3. So I'm going to get x equals 0 for the first one. And if I'm going to solve the second one, I need to add 4 on both sides, and I'm going to get x equals 4 for the second one. Now my last problem that we're going to do here in the video is this. The depth of a submarine can be modeled by the function d of t equals negative 2t squared plus 13t minus 16, where d is the depth in meters and t is the time in hours. What time is the depth of the submarine 1 meter below the water? So if we want to know when the depth is 1 meter below the water, what we want to figure out is when the depth is negative 1. And the reason we're making that negative is because it's 1 meter below the water. So the equation that I would set up would be negative 1 and then equals the negative 2t squared plus 13t minus 16. Now I know I need to rearrange this so that I equal 0. So I'm going to start by adding 1 on both sides. You'll notice I wrote down the plus 1 underneath the negative 16 because those are like terms and they're going to get combined. Negative 1 plus 1 is 0 equals negative 2t squared plus 13t, and then I'm going to have minus 15 because negative 16 plus 1 is negative 15. Now I'm going to look for a GCF. In this problem, the GCF is negative 1, and what's left over would be 2t squared minus 13t plus 15. And of course, we have our equals 0 that I'm just going to bring down. Now I'm going to use my box method to continue factoring. So I'm going to fill in my 2t squared, the first term, and I'm going to fill in my 15. Then I'm going to do my m and my a. In this case, my m would be 30 and my a would be negative 13. So the factors of 30 that are going to make negative 13 would be 3 and 10, and I would just need to make both of those negative. So I would have negative 3t and negative 10t. Now the common factor for the first column is 2t, so this is a t, this is a negative 5, and this is a negative 3. That means my new equation becomes 0 equals negative 1 times, and now I'm going to put in my factors, 2t minus 3 and t minus 5. So this part becomes here. And now I'm going to solve this. So to solve this, each of these needs to be equal to 0. Once again, negative 1 will never equal 0. 2t minus 3 might equal 0, and t minus 5 will equal 0. And I just need to solve those. So to solve 2t minus 3 equals 0, I'm going to add 3 on both sides, and I'm going to have 2t equals 3. Then I'm going to divide by 2, and I'm going to get t equals 3 over 2. Here I'm going to add 5, and then I'm going to have t equals 5. Now it says here in the original problem that t is the time in hours. So I'm going to add a label of hours here and hours here. So I'm going to be exactly 1 meter below the water at 3 over 2 hours, which is 1.5 hours, and at 5 hours. Alright guys, that's it. Thank you guys so much for watching. I will see you for some practice tomorrow. Have a great day.